Right, first question. Number 1. An ideal gas occupies a volume of 7.25 times 10 to the minus 3 at a temperature of 20.4, which is 293.4, and the pressure is 1.37 times 10 to the 5. And then what happens is, determine the volume occupied by the gas at that temperature and that pressure. Okay, so what happens is the temperature increases and the pressure increases. So the temperature increases to 48.7 degrees, so that is 321.7. And then the pressure increases, the pressure, sorry, I wrote this one down wrong. It starts off at 1.52, and then it decreases to 1.37 pascals, 10 to the 5 pascals. Okay, so at the beginning we have PV equals N or T. The P we know, the V we know, and the T we know, and the R we know. So in fact, we can get the N. The N is PV over RT. So the N is, let me hit that in, P 1.52 times 10 to the power of 5 times V 7.52 times 10 to the power of minus 3. Are you giving me the final answer? I might have said it, but typed into 5. I'll see if I get the right answer, or the answer that you got. Divided by temperature, 293.4. What did you get, Tom?
For N?
Yeah.
0.452.
Yeah, 0.452 is what I got here. Yes. Okay. Now here, what do they want? They want to know what the V is. It's different now. So PV equals N or T. So V equals N or T over P. Yeah, that's it. So the N times the R times the T divided by the P. Quite small, yeah. 0.007, oh well, they actually have it as 10 to the minus, sorry. 7.949, so 5, no, sorry, 7.9, yeah, 5 times 10 to the minus 3 meters cubed. Yeah, did you get that? Okay, good. So that's number 1 taken care of, so let's have a look at number 2. Can I scroll down? Yeah. Okay, so number 2. This is the answer. Okay, so number 2. Right, what's this one now? So here we have a cylinder contains gas which is 8 times atmospheric pressure. So the pressure is 8 atmospheres, which is 8 times 1.05 times 10 to the 5. The volume is 0.34 meters cubed, and the temperature is 273 plus 19. So the temperature is 292. Sorry, I must be misreading something here. I am sorry. No, I was mixing up 2 and 3. I was looking at 3. What?
No, your first answer is wrong.
What should it be?
8.8.
So when your teacher says, is this right, and people say yes.
But you were so happy when you said that. Would you like to mix it up?
Thanks. It's 8.82, yeah?
Yeah.
Fine. very considerate of you. Okay, so, next one. Volume is 0.23, N is 1.4, temperature is 273 plus 25, 298. What's the pressure? So PV equals N or T. So P equals N or T over V, which is 1.4 times, well, we just put the numbers in on the calculator, I won't even bother to write it. 1.4 times 8.31 times 298 divided by 0.23. So, is the pressure here 15073.6? So if you want, we can put that in kilos. So that is 15.1 kilopascals is the pressure. Right, now the second part is what's the volume if it was at STP. Now I didn't tell you STP yet, and I did that on purpose because I don't like it. STP means standard temperature and pressure. If you go to Google and type in standard temperature and pressure, unfortunately you get more than one answer. So standard is not standard here. There's different standards used in different places, I guess. So for the physics course, standard temperature and pressure might be different to what you use in chemistry. In chemistry, has Lorraine given you a definition of STP, standard temperature and pressure? No. So in physics, standard temperature and pressure means 0 Celsius and 1 atmosphere of pressure. This is called the standard temperature and pressure. Like I said, I think maybe in America they could use something like 20 Celsius, you know, like a room temperature as standard. Anyway, here standard temperature and pressure is 0 and 1 atmosphere. Okay, so now we have temperature 273, pressure 1 atmosphere. 1 atmosphere. Did I write 1.01 previously? No, I didn't need it for that. Okay. The volume is what we. The 1 here. Sorry, 1. So we have the temperature, we have the pressure, we have the mole number, it's still the same, and this time we want the V. Okay, so PV equals N or T, so V is N or T over P. So we have the answer now. Or does someone have it already? Yeah, what is it? 0.0314? Okay, thank you. Alright, so that's number 2 taken care of, so let's have a look at number 3. Number 3. So the pressure is 8 times the atmosphere pressure, which would be 8 times 1.05 times 10 to the 5. The number of moles, we don't know. The volume we do know. And the temperature is 19 Celsius. So that is 292 Kelvin. What else are we told? That's it. What is it? Determine the number of moles of helium in the cylinder. Determine the number of particles of helium in the cylinder. Okay. So anyways, PV equals N or T. So N is PV over RT. Has somebody calculated that for me?
Is it 1.05 or 1.01?
It's 1.05. See, this is the thing. They're telling in the question what to take as atmospheric pressure. So in this one, this year, they said 1.05.
It's 117.69.
What is it?
117.69.
117.69. So if I took three significant figures, it would be 118, yeah? Okay, I'll take this 69 there, 117.69 moles. So that answers the first part. So there is 117.69 moles of helium. Now helium, I believe, tell me if I'm right or wrong here, helium is not diatomic, is it?
Yes, it's true.
What I said is true, it's not diatomic.
Yes, it's monatomic.
It's monatomic, good, so it's just helium by itself floating around. So how many particles? Well, it's easy, it's just this one multiplied by Avogadro's number. So what do we get then for the number of helium particles?
7.09 times 10 to the 8.
Yeah? Okay. Stupidly easy. Yeah? Right, okay. 4 now. A part 1. What does the N represent? Oh my goodness, number of moles. Okay. Get short now, this one is more interesting. Get the unit for pressure multiplied volume. So the unit for pressure multiplied volume is the unit for pressure multiplied the unit for volume. Yeah? What is pressure? Pressure is, you have just a formula, force over area. And volume is just going to be volume for the moment. So, force, well, we'll do the units now. That's Newton, that's meter squared, and then volume is meter cubed. So they cancel, you get Newton meter, but Newton meter is also a joule. And this makes sense because remember last week I said when you want to work out how much energy is done by changing the volume, it was pressure multiplied change in volume is energy, is work done for changing the volume. Do you remember I did this last week in the double lecture on the kinetic theory? Yeah? No. I don't know if this is the face of understanding or just continue please teacher. Which is it?
In between.
Question, yes?
Is kilogram per meter squared, that was for joules.
Kilogram. Yeah, you can change Newton into kilograms and meters as well, which I'm not going to do, but if it, well actually okay, I will. Newton, F is MA, so that's kilogram meter per second squared. Isn't that right? Over meter squared, meter cubed, so that cancels that to make it squared, and you'll get a kilogram per meter.
No.
Sorry.
Per second.
I still have I have a meter at the top, don't I? Meter squared at the top.
Yeah.
Kilogram meter squared per second squared. Now Joshua, you can look at it like this as well. What's the formula for kinetic energy? A half mv squared. Kinetic energy is in joules, and then this here is kilogram meter squared per second squared. So actually it is the same as joule if you do it this way, although it's not as direct. Okay? So you don't need that, you just need this one here. Okay, that's part A. So part B now. It's 130 grams of CO2 per kilometer. The molar mass equals 44. So what this means is 44 grams of CO2 is equal to 1 mole. The volume we don't know, but the pressure is 1.01 times 10 to the 5, and the temperature is 300 Kelvin. what is the volume? Is it? Yeah, volume. So PV equals nRT. Oh, well, first I should find the N. So the N would be 130 divided by 44. What is that?
2.54.
Yeah, 2.955 moles. So PV equals nRT. So V equals nRT over P. So that is N times R times T divided by P, which is 1.01 times 10 to the power of 5. So the volume I got 0.07 meter cubed. Yes? Right. Okay. Now if I look at the next one, 5, sorry, so the answer here, 0.07 for P. Okay, so 5. Again, it's 120 grams of CO2, and the molar mass is 44 grams. So that means you have, whoops, 2.727 moles. It's per 100 per what is it per kilometer. How many moles are produced in 100 kilometers? Well, that's really easy, because in 100 kilometers, it's going to be 100 of these, if this is every kilometer. So that means we have 272.7 moles. And what's the volume? Well, same thing again. V equals nRT over P. So times that, is it 300 Kelvin as well? Yeah, 300 Kelvin again. Divided by pressure. Um, 6.48? Or did I type in something wrong? Did you get that? No? Oh, the pressure is 1.01, not 1. Okay. Sorry, what did you get?
0.72.
No, hang on. What you get? 6.73. Okay. Right, so that's 5. That's the B part, and this is the A part. Okay, 6 now. Pressure is 2.2 atmospheres. The temperature is 300 Kelvin. And the cylinder, the container is a cylinder. So it looks like this. And the radius here is 5 centimeters. And the length is 1.9 meters. So we can work out the volume. It is pi or squared h. So the volume is 0.0149 meters cubed. Did you get that too? Yeah? Okay, so what is the... Oh! Actually that's the... Hang on. No, that's not... I'm sorry, did I type in 1. Yeah, 0.0... Am I mixing up my questions? The length is 1.9. It's... Oh, sorry, diameter is 5 centimeters. Not the radius, so I should divide this by 2. So it means that my answer is too big. 3.73 I got. Yeah, that's what it should be. .73 times 10 to the minus 3. Okay, that's the A part. The B part, what's the pressure? They give it to you. Oh my goodness. 2.2 times, what's wrong? Pressure is 2.2 atmospheres, which equals 222200 pascals. Or if you want 22.2 times 10 to the 4 pascals. That's all they want for it, isn't it? Yeah. You know how to multiply, don't you?
Are you sure that this is not to multiply?
Well, they give you, they say the pressure. Oh no, hang on. Hang on. There's a key word here. Excess, which I didn't see. So I think this, yeah, it felt too easy. If you look at the question, it says the excess pressure is 2.2.
But the next question says calculate the moles. And
Yeah.
you don't have the moles for the second.
No, it says the excess pressure is 2.2. That means the pressure is 3.2. Why is it 3.2 and not 2.2?
One is normal and...
Yeah, 1 atmosphere is normal pressure. So if the excess is 2.2, it means they added an extra 2.2 atmospheres of pressure into it. So now, again, still multiplying. 3.2 times 1.01 times 10 to the power of 5. So now I get 3.23 times 10 to the power of 5 pascals. Okay, C, the moles. PV equals nRT. So N is PV over RT. So I have my P. I have my V. I have my R. And do I have my T? Yeah. So I got here 0.484 moles. Okay. D. That's the number of moles. How many molecules are there? Well, that's just number of moles multiplied by Avogadro. What's Avogadro? 6.01, is it? Or 6.02 times 10 to the 25? 23. So that is 2.91 times 10 to the 23 molecules. Would the number of molecules be more or less at the same if the tire were filled with hydrogen instead of air? Well, let's have a look at what they're saying. So can we just recap? P, V, N, or T. Okay, so what's the P? What was it? It was, I'll just write in as atmospheres. 3.2 atmospheres. What was the V? The V? Come on, children, what was the V?
3.735 times the minus.
Okay, and what was the N?
0.484.
Okay, and the R is 8.31 and the T is 300, and the big N was, what was it? 2.91 times 10 to the 23. Okay, and this is with air. Now what they do is replace it with hydrogen. PVN or TN. And they would like to know, state whether the number of molecules will be more or less or the same if the tire is filled with hydrogen. So they want to know the number of molecules. They want to know if the big N is the same or different. So what I'm going to assume is if they fill it with hydrogen, the volume is still the same. So this is the same. This is still the same. The temperature will be the same because it will be at the room temperature, which was 300 Kelvin. So the temperature we'll put as the same. The pressure, I don't know. I will assume it's the same because they didn't tell us anything was different. I guess they're trying to say if you fill it up to the same pressure. I don't really know about, do they say about the pressure?
No.
Oh no, they say it there, at the same temperature and pressure. They say in the question, same temperature and pressure. Okay, so the question then is, would the number of moles be the same? What do you think? Yes, it would be. Because what's the formula? PV equals nRT. So what's the formula for N? PV over RT. If all of these numbers are the same, then will the small n work out to be the same? Yeah. So this is the same. So then the big question then is the big N the same? What do we think now? Yeah, so if we have here, I have 0.484 moles of air, whatever the air molecule is, doesn't matter, and I have 0.484 moles of H2. So then how many molecules of H2 will I have? Well, I just have to multiply it by Avogadro. So I'll get the same number. So the answer is actually the same. Not more, not less, but the same. Okay. Last one now. This question every year, I do this one every year, and it always catches people out. They feel like the N should be different, but in fact, you can see that from the formula, it's the same. Right, 7. V 0.0075 T 300. The pressure was 12 atmospheres, but then it fell to 10 atmospheres. And 1 atmosphere is 1.01 times 10 to the 5 Pascal. How many moles are in the cylinder of gas? So N equals PV over RT. Does someone have this number for me? I think they want it at the start, initially, yeah. Yeah, what is it again? 3.646 moles. Okay. Now what we can do for the next part is we can calculate the new value with the new atmosphere, and then the difference is how many moles were used, how many moles were released. So I'll just hit it in here. Okay. So here I get 3.039 moles. So therefore, .607 were used, because that's the difference between the two tanks. Did you get that too?
I didn't see the question.
Okay, because it was on the back. The people who did it, did you get that? You're not just saying that to make me happy. It's very sweet of you, but you did get that, yes?
Yeah.
Alright. C What was the volume of the gas used at 1 atmosphere pressure, assuming the temperature remains the same? So what you picture, guys, look up, is this gas leaves the tank, how many moles left the tank? 0.607. But then what happens when it enters the room? Its pressure changes to 1 atmosphere. Yeah? So we have P is 1 atmosphere, N is 0.607. The temperature is still room temperature, and we want the V. So V, PV is nRT. So V is nRT over P, which is uh, 607 times 8.31 times 300 divided by 1.01 times 10 power 5, 0.0149, so 15 meters cubed. That's the volume of the gas that was released and now is in the room. So there's 0.015 meter cubed of this hospital gas in the room, or in the person, wherever it went to. Okay. Yes. So like I said, these are good questions for your physics exam to have. If you get it, you do it.